Hello students, let us discuss the concept of RSA operations. RSA operations concept we are going to use to generate a public key or a private key pair. So once this pair is generated, no need to generate these values again and again unless it is compromised. So it is a one-time operations. The steps used in RSA algorithm is choose the prime values p and q, using which we are be calculating the n value as p into q. Second step is we are going to find the encryption key E such that GCD of E, phi of n is equal to 1. The meaning of this is the value of E and phi of n must be co-prime values. So once the value of E is found, we are going to call a public key as a pair E, n, where both are integer values. The next step is to find the private key D, which is D is equal to e to the power minus 1 mod phi of n. We are going to call D as the private key value. The formula to find the phi of n is p minus 1 into q minus 1. The encryption is done as follows. The given message m will be divided into a various number of blocks, and the length of each block for the given message m is given by the value b, where we have b as ceiling function of log n. That is, b represents the number of bits used in n, where we are going to refer to as the key size. So for each block mi, we find corresponding ciphertext ci, as ci is equal to mi to the power e mod n, where e is the public key which we have calculated in the second step of RSA algorithm. The next step is the decryption, where we will be getting back the corresponding plain text mi corresponding to the block I, using the formula ci to the power d mod n, where d is the private key again, where we have calculated d as the value of private key in the step 3 of the RSA algorithm. So let us consider the values p is equal to 3 and q is equal to 11, and the given message m as 00111011 in the form of the binary representation. And we have n is equal to p into q, which is 33, where we are going to calculate the n value. And similarly phi of n, which is p minus 1 into q minus 1, where we have 2 into 10, which is equal to 20. So where we have 2 is equal to 3 minus 1 and 10 is equal to 11 minus 1. Now, once we have the value of phi of n, now we are going to calculate the e value such that we have GCD of e, phi of n is equal to 1. Now suppose if you try with e is equal to 2, we have GCD of 2, 20, which is not equal to 1, where this 20 is the value of phi of n what we have calculated here. So I will try for e is equal to 3. So we have GCD of 3, 20 is equal to 1. So since 3 and 20 are co-prime, now I am going to find the d value now here using the formula e to the power inverse mod phi of n. So to find the inverse of a number, we already know the steps as we discussed in the class. So using that, I will be getting the inverse of 3 as 7. So we have d is equal to 3 to the power inverse mod 20. So we are having the 7 as the private key. So now we have got public key as well as private key. Now we can proceed with the encryption and decryption process. So if I want to do the encryptions or decryption, we are going to divide initially the given message m into blocks. So size of the block is given as b is equal to 6. That means here I have the given message as 00111011. I will be dividing this into 2 blocks, where in the block 1 I am having the first 6 bits 001110. The remaining 2 bits I will be considering it for the block 2. So again in the block 2 we need to make it as a 6 bits. So we will be padding the 4 zeros in front of these 2 left side to make it as 6 bits. So the given message m 00111011 is divided into 2 blocks. Block 1 is with this value 001110, which is corresponding to the plain text m1, and block 2 has 4 zeros followed by 2 ones, which is a block message text 2. Now we are going to encrypt message 1 separately and M2 separately. Similarly, we will be getting back the ciphertext corresponding to M1 and the M2. So the procedure to do the encryption is we will be making use of the formula as we discussed. C1 is equal to M1 to the power E mod N. So we are finding the ciphertext for each block here separately. So at the first time I will be considering the block M1. Second time I will be considering the block M2. Like that we will be proceeding. So we have E is equal to 3 value, M is equal to 14. We are going to substitute all the values here and we will be finding the values. So now at various stages we can make use of the concept of reduction modulo, where it helps to maintain a bound on the size of the numbers involved. So at this step we have 196. So 196 we will be finding the value nearest to the 196, which is we will be getting using 33 into 6, where 33 is the value of the n. So 33 into 6 I will be getting it as 198. So 196 minus 198 we will be getting it as minus 2 here. The reduction modulo step here you are applying here, okay, by finding the nearest value 196. Nearest value to the 196 is 198. So we will be applying the reduction modulo by using the value of n, and we will be multiplying value with some quotient values. So to find the nearest value to this value what we have here. Okay. So into 14, where this 14 is the previous value what we had in these steps. So again I have minus 2 into 14, which is a mod 33, minus 28 mod 33, I will be getting 5. Okay. So now the plain text corresponding to the ciphertext C1, which is equal to 5, we should get back it as 14. So I will be doing the decryption process now. So we will be getting back M1, which is equal to C1 to the power D mod N. We have C1 is equal to 5, D is equal to 7, where D is the private key. So while doing encryption, we will be making use of the public key E, and while doing the decryption, we will be making use of the private key D. So now again, here we have expanded the value 5 to the power 7, and we have 25 into 25 into 25 into 5 mod 33. And again, here we have for 25, we have applied the reduction modulo here. So that is, we are getting for 25 it is minus 8. That is 25 minus 33 into 1. The nearest value to the 25 is, I have 33 only. And here 33 is the value of the n. I cannot make use of any other value other than n. So I will be using 33. And I will be finding the other multiplier value which we are supposed to do with the 33 to get the value nearest to the 25. So 33 into 1. So 25 minus 33 is minus 8. Similarly, for this 25 also minus 8. For this 25 also minus 8 into 5 mod 33. So we have minus 8 into minus 8 64 into minus 8 into 5 minus 40 mod 33. So again here also reduction formula is applied. The values nearest to the 64 is 66. So after subtraction it is minus 2 into minus 40 mod 33. Again 80 mod 33. Again apply the reduction modulo here. 80 minus 33 into 2. 33 into 2 is 66. 66 the nearest value to 80. So I will be getting 80 minus 66 as mod 33 as 14. So we got back the plain text M1, which is equal to what we had before doing the encryption. Similarly, the same steps we have applied here to find the encryption and decryption for the second block of the text M1 and M2. Okay, we have applied the same steps for encryption and decryption of the second block M2. M2 is 3. I am getting the ciphertext C2 as 27. Here C2 we are getting back the M2. the plain text block empty we are getting back here by using C2 to the power D mod n. Our C2 is 27, D is 7, mod 33. So we have expanded here, and we have multiplied to 27 into 27, 729 you will be getting back. So again apply the reduction modulo step here. 729 minus 33 into 22 you will be getting it as 726. Okay, so 729 minus 726 is 3. Similarly for this also 3, for this also 3 into 27 mod 33. So here I have the value 729 mod 33, where I have 27 into 27 as 729. Again 729 minus reduction method we are applying here again. So 33 into 22 I will be getting it as 726. So 729 minus 726 is remainder is 3 mod 33. So value is 3, which is the value of M2 we had. So we are getting the correct answers here. So the point to remember here is in real-time applications, the modulus value n and the decryption key d value will be hundreds of digits long. And if I consider the software performance, we can make use of the Java APIs, which are relevant to the cryptography applications, which can be used for the key generation, encryption or decryption purpose, where we will be finding the lot of classes in java.security package and other sub-packages. Other practical issues to be considered are generating the prime values like P and Q in RSA algorithm, then side channel and other attacks, where we will be concentrating on modulus factorization, small exponent attack and side channel attack. Thank you, students.